Alright guys, so sorry. I am so late putting up your homework today. So if you already finished it, nice job, and you want to just check your answers, or if you've been waiting for me to post it, I am so sorry. I got caught up calling parents, doing all kinds of stuff today. So here is the rest of your homework. Yeah, because we started it a little bit. So the rest of your homework for today. So I took off the other pages, but I will do them. I'm going to just do this part first, and then I'll go back and do these in case you did them and you want to check your answers and see how you did. So anyway, we are right here. So number 2 across. Oh, sorry, I'm on page 783. So number 2 across, right? I did number 1 across. And then I did number 6 down and 4 across. So I'm on I only have 1, 2, 3, 4, and 5 across. So 2 across, the number that divides the dividend. So the number that divides the dividend, right? And if you don't know, it's going to be 1, 2, 3, 4, 5, 6, 7 letters. So you could look up here trying to figure out which one has 7 that would fit. I could do one down or across that I know better, but I do know this answer, so hopefully you got it. I feel like Dora the Explorer. And it is divisor. Good job. So the divisor divides up the dividend, right? If I have a division problem, I would say 8 divided by 2 equals 4, right? This is my quotient. My answer to a division problem is the quotient. The number I am dividing up is my dividend. And the number that I'm dividing by is my divisor, right? If I was going to do this in my little house, I put my dividend inside the house, my divisor goes out, and my quotient 2, my answer 2 times 4 is 8, no remainder. Alright, so number 3 across, a number that is being divided. Oh, well, they just told us right there, right? But we can double check. 1, 2, 3, 4, 5, 6, 7, 8 letters. 1, 2, 3, 4, 5, 6, 7, 8. It fits perfect. My dividend is the number that I'm dividing up, right? I have 8 of something. I'm going to divide it up into groups of 2. So there's 1, 2, 1, 2, 1, 2, 1, 2, and I end up with 4 groups. All right, number 4 we already did across. Number 5, operations that undo each other, such as multiplication and division, right? That's why I say they're a fact family. 8 divided by 2 is equal to 4, and 4 times 2 is equal to 8, right? They go together. These numbers are going to go together. The same addition and subtraction are opposite, right? So if I have 3 plus 2 equals 5, right? If I undo it, I know that 5 take away 2 would be 3, and 5 take away 3 is 2, right? They are and you could see this one's a super long one, right? So which one's long up here? I'm not going to leave the space in my crossword puzzle. Operations has 1p. Inverse operations, they undo each other. I use them, right? If I have algebra and I have this 3 plus something, I don't know what, equals 5, right? I could use subtraction to figure out what it is. 5 take away my 3 equals 2. Oh, 2 would go there, right? That's why I'm saying these go together. So if 8 divided by something you don't know what it is, do you know 4 times something? 4 times 2 is 8. All right, next one. 6 down, we already did. 7 down, a number that has a whole number part and a fraction part, right? If it has a whole number and a fraction, I call it a mixed number. It would look something like this: 1 and 1/2, or 3 and 3/4, right? It has a whole number, 3 whole pizzas, and then a little bit more pizza. So my 7 down is a mixed number. And last but not least, number 8, a number that represents part of a whole or part of a set, right? My fractions are part of a whole or part of a set. Is a fraction, right? Right here, you can see I have 1, 2, 3, 4 things to write with. I won't count the one in my hand, right? I could tell you that 1/4 of my things are pencils, or I could tell you 1/4 are red, or I could tell you 1/4 of my writing utensils is green, right? If I add one more in here, now I have 5. Now I have 1/5 of my writing utensils is a pencil. 4/5 of my writing utensils are pens. So that's all I'm doing, right? I can also break up a whole thing, right? If I have 1/3, 1/3, and 1/3, I need one more third here, I would have one whole piece. All right, on to the back and our math here. So now I have 1/5 times 22. So we're multiplying fractions. So when I multiply fractions, I have to multiply the numerators and the denominators. Right, this one does not have a denominator, so I'm going to just add one in there, and it's going to be 1. I can turn any number into a fraction by just writing a 1 underneath it. Right, don't get that confused with a unit fraction. A unit fraction is one piece, like 1/6, 1/6. If I broke something up into 6 pieces, sorry, I only have 5 of them here. I need one more to make one whole. This is a unit fraction. This is just a fraction. I can turn any number into a fraction, but a unit fraction has the 1 on the top. All right, so sorry, now I'm going to multiply. So I multiply my numerators and my denominators, and I end up with 22/5. And hopefully you realize we cannot leave that like that, right? And here I was only estimating anyway, so maybe I could have done 1/5 times 20. It would have been a little easier problem. But I'm just going to work it out since we are practicing. 22/5, I cannot leave it like that, right? I could do a couple different ways to figure out how to do this. I can just divide, because that's what a fraction is. It's a division problem. So I'm going to put 5 into 22, my dividend, my divisor. So 5 can go into 2? No, it cannot. Can 5 go into 22? Oh, yes, it can. How many times? 4 times. 4 times 5 is 20. I subtract, I get 2. My 2 becomes my new numerator. 5 is still my denominator. And my answer would be 4 2/5. But I was doing a fraction here, right? So I'm going to say 4 2/5 is closer to 4 than it is to 5. So I'm going to say 4 2/5 is almost 4. My final answer would be 4 since they asked me to estimate. Right? There's other ways I could do this. I could figure out how many 5/5 are in this 22. Right? I could say 5/5 plus 5/5 plus 5/5 plus 5/5. Now I have 5, 10, 15, 20. I needed 22 plus 2/5 would be my, if I was just working this out by my reverse operation like our book told us to do this. Just kind of figuring out, right? I know multiplication is repeated addition, so I'm just repeated adding, and 5/5 is 1 plus 1 plus 1 plus 1 plus my 2/5, which I can't do anything with, right? 1 plus 1 plus 1 plus 1 is 4 2/5. It's hard to see on a number line where 2/5 is closer to 0, but if here was my number line, right, here's my 0, here's my 1, I'm going to break it up into 5 pieces. So I could see the middle here. I'd write, I have the 2 on this side, 2 on this side. My middle would be right here. Right, this is 2.5, 2.5. Here's my 2/5 that I'm looking at, right? 1, 2/5 would be right here. So I could see this is closer to 0 than it is to 1. So I'm going to round it to 4. All right, number 12 over here, 26 times 1/2. This time I am going to just regular multiply, and I'm going to write it in its simplest forms. So first things first, I'm going to turn both numbers into fractions. Then I'm just going to multiply my numerators, 26 times 1, and 1 times 2, and then I'm going to reduce. All right, this is an even number, so I know 2 can go into an even number evenly. All right, so I'm going to take 26 and divide it by 2. Can 2 go into 2? Well, yes, it can. One time. 1 times 2 is 2. I subtract, I get 0. I bring down my next number. It's a 6. Can 2 go into 6? Yes, 3 times. 3 times 2 is 6. I subtract. Now I have 0, no remainders. I'm great. So 26 divided by 2, 26 halves is 13. Final answer. All right, over here I'm multiplying two fractions together. I just multiply my numerators and my denominators. So I'm going to say 1 over 5. Sorry, I didn't need to rewrite it. Let me pause and erase. Doing so many divisions, I'm used to flipping them, but I don't need to here, right? I'm just going to multiply my numerator. 1 times 3 is 3, and 5 times 8. Right? If you don't know, look it up in your charts, look it up in your books, right? It's right over here in the back of your book. 5 times 8, you could count by 5s also, right? There's my 5, there's my 8, they meet at 40. Or I could count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. That's 8 times, right? I added 5 together 8 times. 3 over 40. There's no way I can make this smaller, right? 40 could be divided by 2 or 10 or 4, but 3 can't be divided by 2 or 4 or 10. I can't do anything to the bottom and the top divide by the same number. And it's not improper, right? The smaller numbers on top, the bigger numbers on the bottom, it just stays like that. All right, over here, next problem. I'm going to say 1 times 7 and 2 times 8. And again, same thing. 7 can be divided by 7 or 1, but 16 can't be divided by 7. Right? 2 times 7 would be 14. That's not going to work. It has to be evenly divided into the numerator and the denominator. All right. If you need to pause, then pause because I'm going too fast. Just do that, okay? I'll try to slow down my speech, though, and talk a little slower. All right, so 3 and 1/4 times 3/5. We can't do it yet. I have a fraction here, but I also have a whole number. So I'd have to multiply my 3 times 3/5 and my 1/4 times 3/5. So what I'm going to do is just turn this into a fraction. The way I turn this number into a fraction is I take my denominator and I multiply it times the whole number, which would be 12, right? So I multiply here, and then I have to add that 1 back into it. So now I'm going to have 13 over 4. And now I can multiply that times 3/5. So I'm going to take my 13 times my 3, right? I can just add 13 plus 13 plus 13, right? This is a harder one. I can do that. 3 plus 3 plus 3 is 9. 1 plus 1 plus 1 is 3. So I'm going to end up with 39 on the top. Right? It's not even in my chart. But one thing that is in my chart is 3 times 10 and 3 times 3. I could have done that as well, right? 13 times 3 is the same as 10 times 3 plus 3 times 3. Right? Because 13 is 10 plus 3. So I could break it up like that if this seems like a hard problem, because this now is easier, right? 10 times 3 is 30. 3 times 3 is 9. 30 plus 9 is 39. I love math. We got the same answer. 4 5s, though. We can just count by 5s. 5, 10, 15, 20. I could also count by 4s, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I still get 20. 39 over 20. Can I leave it like that? Say no. No, right? Why? I can't divide the same number into the top and the bottom, but the problem here is it's top heavy, right? This bigger number is on top. So there's a couple different ways I could figure this out. I could just divide 39 by 20. Can 20 go into 3? No. Can 20 go into 39? Yes. One time. 1 times 20 is 20. I'll subtract. I get 19. 19 is my new numerator. 20 is my new denominator. Now, can I make this any smaller? No, because I can divide 19 by 19, but I can't divide 20 by 19. And there's no other number I can divide up into 19. So my final answer is going to be 1 and 19 over 20. Your other way you could do this, right, is reverse I can just try and figure out what two numbers I could add together. Right, I want to make my 20 over 20 to get that out of there. Then I'll have a 20 here. Sorry, it's running into that problem. So I know 20, 20, right? My numerators stay the same in addition with fractions. And I know 20 plus 19 would give me my 39 on the top. And I know 20 over 20 is 1 plus 19 over 20, same answer. I'm just double checking, right? Make sure I got the right answer. All right, here I got 2 of them I got to turn into fractions. So what I do is I take my denominator and I multiply it times my whole number. Right, all I'm saying is that would be 8 eighths plus 1/8. Now I'm going to add in that, right? It's going to be 9 eighths times 3 times 3 is 9, plus 2, 11 over 3. Now I can multiply, right? This is getting real big, so you're like, it's starting to look scary like a monster, but you can do this, right? 9 times 11, you could look in your chart, or 9, oh no, it's not on the chart, because my chart only goes to 10s. Oh no, this one does it because it's go to 12s. I don't know. Anyway, 9 times 9. Hopefully you remember that one, is 99. 8 times 3, a little trickier one. 8 times 3 is 24. But I will not leave it like that, right? It's top heavy. This number on the top is bigger than the number on the bottom. So this is one of the problems where I think it's just easier to divide. Right? I know it looks crazy and hard, but right, sometimes I do my division, and I always do my math with a pencil so I can erase it. Right, I know 2, right, if I just look at my numbers in the tens place, 2 goes into 9 4 times because it would be 8. So let's try a 4 and see if that will work, right? If it's not, I just erase and start over. But I'm going to say 4. My other clue here is, right, I know 25 would go into 100 4 times. So we're going to do our math here. 4 times 4 is 16. Right, I can't just write my 16 here because I have numbers in the tens place, so I have to do that first and then add that back in. 4 times 2 is 8 plus 1 is 9. I subtract, 9 take away 6 is 3. There's my new numerator and my denominator. And hopefully you caught this. 24 and 3 can both be divided by 3. Right, 3 can easily be divided by 3. 24 divided by 3, right, is 8. Right, with my inverse operations here. So I still keep my 4 just the same. 3 divided by 3 is 1. 24 divided by 3 is 8. Final answer is 4 and 1/8. All right, we did these ones in class today, but I did not check them. Right, 2 divided by 1/6. I take my 2 and put a 1 over it. And I take my operation dividing and I switch it and do multiplication, and also I switch my divisor and put the 6 on the top, the 1 on the bottom. I switch my numerator and divider. Now I multiply. 2 times 6 is 12, 1 times 1 is 1, and 12 over 1 is just 12. We can double check and make sure, right, because my inverse operation, if 2 divided by 6 is 12, then 12 times 1/6 should be 2. So we'll check it. 12. right? It's going to be 12 over 1 to do my fractions. 12 times 1 is 12, and 1 times 6 is 6. Right, there's different ways I could do this. I could divide, I could figure out how many 6's are in 12. I could divide the top and the bottom by the same number here, because I see this is going to get me to 1, and I know that will be a 1 on the bottom, right? Which I won't have any remainders, and I won't be top heavy anymore. 12 divided by 6 is 2, and 2 over 1 is 2, which is what we started with. All right, so these are different, right? This one, I'm taking my whole number and dividing it up into sixths, and I will have 12 sixths when I'm finished. This one, I already have my fraction here. I'm going to divide it up into 5, and then I want to figure out what if of the whole piece I have. Right now, I only have 1/15 of it. I took my 1/3, I divided up into 5 pieces, 5 pieces, 5 pieces. All together, one of them is going to be 1/15. All right, hopefully that makes sense. I did my math over here though, right? 1/3 divided by 5 is the same as divided by 5 over 1. So to divide fractions, I change my operation to multiplication. I find the reciprocal, which is 1 over 5, right? I flip it. And now I can multiply. 1 times 1 is 1. 3 times 5 is 15. Let's double check. 1/3 divided by 5 equals 1/15. So 1/15 times 5 should equal 1/3. So let's double check it. Don't die on me now, pen. All right, so I'm going to multiply across here. Right, 1 times 5 for my numerators. On the bottom, I'll have 15, 1. And I wouldn't leave it like that, right? It can be reduced into simpler terms, because if I can do it to the top and the bottom, I can reduce my fraction, right? Just like this is what I'm doing. I'm saying if I had 2 6's, it would be the same as 1/3, right? I have 2, I could divide the top by 2. If I had 2 6's, I divide the top by 2 and the bottom by 2, and I have whole numbers on both. 1/3. I'll cross this out, that was just for us to look at, so it wasn't even a problem on the page. All right, so 5 divided by 5 is 1. 15 divided by 5 is 3. My answer, 1/3. Checked. All right, and that was your homework for today, guys. I did ask for these ones also. Maybe I will. Sorry, I'm already 22 minutes in though, so if you didn't do these ones, just turn me off now and turn in this page. I didn't want you guys to do any word problems. I know it will take a long time, but I'm just going to do these just because you know me, I love math. Ken is working on a project for social studies. He has a piece of poster board that needs to be divided equally into 1/3 foot sections. The poster board is 4 feet wide. How many sections will Ken have on the poster board? All right, so right here's his poster board. It's 4 feet wide. He's breaking it up into thirds sections, right? But it's 4. We'll pretend like that's 4 feet. I don't know. And he's going to break it up into thirds, right? So how many pieces is he going to have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So I'm saying he has 4 feet and he's dividing it up into pieces that are 1/3. I'm going to turn this one into a fraction. Now I'm going to do my work. 4 over 1. I change my operation to multiplication. I flip them. Find the reciprocal. 3 over 1. 4 times 3 is 12. 1 times 1 is 1, and 12 over 1 is the same as 12. And what are they asking? 12 what? How many sections? 12 sections Ken will have. All right, and here is Samantha. Samantha measured the dimensions of a rectangular poster frame. It was 3/4 yard long and 1/2 yard wide. What is the area? Oop. Math, right? If I'm finding the area of something, I multiply the length times the width, right? Picture, here's her thing. This is 3/4. This is 1/2. I multiply these two numbers together. 3/4 times 1/2. Multiplication, I just do straight across, right? I don't switch anything. I just multiply straight across. 3 times 1 is 3, and 4 times 2 is 8. So her thing is 3/8 of a square yard. Because when I find the area, I'm finding the inside, so I'm squaring it. I don't know if that makes sense, but I'm going to leave it at that. All right, so at Middle Avenue School, 1/30 of the students on the track team are on the track team, sorry. The track coach offered to buy pizza or subs for everyone on the team, right? And there's 1/30 of the school is on the team. So of the students for whom the coach bought food, 3/5 ordered pizza. They could have got a sub, sandwich, or pizza. What fractions of students of Middle Avenue School ate pizza, right? Of these 1/30, what percentage of them ate pizza? Okay, so I'm going to take my 1/30 of the school and I'm going to multiply it times the 3/5 that ate the pizza. I'm going to have 1 times 3 is 3, and 30 times 5, right? 3 times 5 is 15, and then I'll add my 0 back on. But we can't leave it like this, right? Hopefully you guys see that this number can be divided by 3. This number also, right? Because 15 can be divided by 3. I know 150 can also be divided by 3. So we could do our math over here. 150 divided by 3. 3 can go into 1. Nope. 3 can go into 15. Yes. 5 times 3 is 15. Subtract, I get a 0. I bring down my other 0. Something times 3 is 0. 0. 0 times 3 is 0. Subtract, no remainders. I'm done. My answer is going to be 50. So 3 divided by 3 and 150 divided by 3. So 3 divided by 3 is 1. 150 divided by 3, we just did this over here. So the kids at the school that ate pizza, 1 out of every 50 kids ate pizza, right? They don't just have 30 kids at their school. So 1 out of every 50 kids. If they had 350 kids, right? 1 out of every, so it just, you'd have to count and figure out how many kids they had. I'm just finding out the percentage, the fractions of them. All right, so here is Saraid is dividing 1/4 a pound of cashews into 5 plastic bags. What fraction of the pound of cashews will be in each plastic bag? Right here they're even telling me he's dividing it up. It doesn't tell me if it's a he or she. It says to draw a model to help me solve, so I could do that. But I'm just going to do my math. So I'm going to say 1/4 divided up by 5. So I'm going to turn this into a fraction, and I will still have my 1/4, but now instead of dividing, I'm going to multiply, and I'm going to flip my divisor. I'm going to find the reciprocal. Numerators, multiply, 1 times 1, 1, 4 times 5, 20, 1/20 of a pound. All right, one more. Ooh, I might make it under the 30-minute mark. The Great Rope Company sells a rope that is 5 feet long. Juan wants to make sections that are 1/3 foot long. How many sections will Juan be able to make? Use a model. So here's my model here, right? He has 5 feet of rope. He wants to break them up into thirds of a foot for each one. Right, here's my 5 feet. He wants to break it up into thirds. So I'm going to take my 1, 2, 3, 4, 2, 3, right, I have 5 sections. 1, 2, 3, 4, 5. I'm breaking each section up into thirds. So now I'm going to do 2, 2. And I could count all of these pieces. And hopefully you could see we'll have 15. I got a couple seconds to do the real math problem, right? I could say 5 divided by 1/3 is the same as 5 over 1 divided by 1/3. I multiply my numerator, I take my 5 over 1 and I switch it to a multiplication problem. And now I'm going to take my 1 over 3 and switch it to 3 over 1. And 5 times 3 is 15. 1 times 1 is 1. 15 over 1 is the same as 15. I have the same answer. Done.